Hi guys, welcome to my channel, and today in this video we are going to discuss instruction cycle. So guys, for the full video, all of you stay tuned.
Karanjetlilive.
So guys, when we talk about instruction cycle, basically what is instruction cycle? It is the cycle in which the computer executes the different instructions. So when we talk about instruction cycle, the instructions are executed in three phases, or they are executed in three stages. First stage is called as fetch stage. What is a fetch stage? Stage is when we bring the instruction from the memory to the CPU so that it can be executed. Number one. So number two stage is decode. So here the CPU decodes the instruction and tries to understand what type of instruction it is, whether it is arithmetic instruction or it is logical instruction or it is data movement instruction. So depending upon the type of instruction, we go to the last stage. We call it as execute stage. At this stage, the computer, it actually executes the instruction. Okay, and the instruction execution, as I told you, is dependent from instruction to instruction. It changes from instruction to instruction. If it is data movement instruction, then the execution is different. If it is arithmetic instruction, then the execution is different. So guys, now let us discuss the first stage, that is the fetch stage. So guys, before we start with the fetch cycle, so we need to understand the basic organization of the CPU and memory, and how memory and CPU are connected. Okay, so guys, this is the CPU and these are the different CPU registers which play a very important role, in the fetch cycle. Okay, and I have another video where I have explained the job of each and every CPU register. So I will put the link of that video in the description section. So guys, this is the CPU and these are some special purpose CPU registers, that is memory address register, program counter, memory buffer register and instruction register. So this is our CPU and this is the memory. Okay, our program which we want to execute is stored in the memory. So here the program which I am using is a simple code of assembly language which shall add two numbers, that is 10 and 20. And guys, CPU and the memory, they are connected with something called as system bus. So what is the job of bus? The job of bus is to carry data, instruction and control signals from one part of the computer to another. Okay, so this bus, it can carry three things: control signals, data and the address. So the memory and the CPU, they are connected to each other using the bus. So if you understand up to here, okay, so let me do a quick revision. We have a memory where our program is stored. We have a CPU which has some special purpose registers, and this CPU and memory, they are connected to each other using a system bus. And system bus is divided into three parts. So one part of the bus carries the control signal, another part of the bus carries the data or the instruction, and third part of the bus, it carries the address. Okay, now let us do the fetch. Suppose guys, now we are at the present instruction. Suppose this is the present instruction. We have executed it. Now I want to bring the next instruction to the CPU. Okay. Now while this is the present instruction, so let us write the contents of different registers. What is MAR? It stores the address of the present instruction. So suppose this is the present instruction. What is the address? 100. So what goes in 100? MAR 100. So what goes in program counter? It stores the address of the next instruction. So present is this, so next is this. So what is the address of next instruction? 110. So then we have IR. we call it as instruction register. What it stores? It stores the present instruction. So what is the present instruction? Move a comma 10. Move a comma 10. So this assembly code can be little different, but what we are trying to do is I am trying to move 10 to A. A is what? A is my accumulator. So this is my present instruction. So what is MBR? For the time being, we'll keep it empty. Okay. Now suppose this is the present instruction. Computer has finished executing it. So it wants to bring the next instruction to the CPU. What that cycle is called as? It is called as fetch cycle. Fetch means to bring something. Okay. So first step of fetch. Move the contents of a program counter to MAR. Whatever is in program counter, move it to MAR. Okay. Now guys, what is in my program counter? 110. I move it to MAR. So what comes in my MAR? MAR comes 110. In MAR comes 110. Then next step, load the contents of MAR to the address bus. Okay, so what happens? Address bus gets whatever is in MAR. So what is in MAR? 110. Okay, 110. Then put a read signal on the control bus. Okay, so then put on control bus, put a read signal. So on control what goes? Read signal. Okay, so what happens? I get the address from the address bus, I put it on from the MAR, I put it on the address bus and I instruct the memory. Okay, whatever is there on memory location 110. Okay, read it and copy it to the data bus. Read it and copy it to the data bus. So what is at 110? This. So then what comes on data bus? Move B comma 20. Move B comma 20. So from the memory I loaded the instruction to the bus. Now bus brings that instruction to my CPU. Then what is the next part? Copy the content of data bus to MBR, memory buffer register. So guys, whatever the things come from the memory to the CPU are stored here for some time. It is a temporary storage of data which comes from the memory to the CPU and which goes from the CPU to the memory. Okay, so then what happens is from data bus, so what do we do is we copy it to MBR. So what is in data bus? Move B comma 20. Move B comma 20. Then what we do? Load the contents of MBR to IR. So in IR, whatever is in MBR, you copy it. So this is the old value. Now we will put the new value to MIR from MBR. So what comes here is B comma 20. B comma 20. Then what is the last part? Increment the program counter. I will put it. PC is equal to PC plus 1. So whatever is in program counter, increment it to point to the next memory location. So right now program counter is 110. What is next memory location? 120. So instruction came to the CPU and our fetch is done. Now this is our present instruction. So guys, let us do the fetch again completely, quickly. So copy the contents of program counter to MAR. So whatever is in program counter, copy it to MAR. Then copy the contents of MAR to the address bus. So what is in address bus comes now? 120. Go to memory location 120 and perform a read. And whatever is there at memory location 120, it will be copied to the data bus. So what comes to data bus? Add B. Add B. So then what do we do? The next part, copy the contents of data bus to MBR. So what is in data bus? Add B. Copy it to MBR. So what comes here is add B. Then copy the contents of MBR to IR. So what comes here? Add B. Okay. So then what do you do? Last step, increment the program counter. So now what is the next instruction? Present instruction becomes this and next instruction becomes this, and fetch is done again. Okay. For your quick revision, let us do one more fetch. Copy the content of program counter to MAR 130. Load the address from MAR to address bus 130. Perform a read. Now what is the read here? Read is move C. Okay. Then load the content of data bus to MBR. So what comes here is move C. Then copy the content of MBR to IR. So what comes here? Move C. Then increment the program counter so that it can point to the next instruction. And guys, our fetch cycle is complete. I hope you understand up to here. So the next two parts are decode and execute. Now guys, in this part of the video, we will discuss decode and execute. Okay. So guys, into decode instruction, so one part of the CPU, it plays a very important role. We call it as control unit. We call it as control unit. Okay. So it decodes the instruction and depending upon the instruction, it executes it. And guys, the execution of the instruction is dependent upon from instruction to instruction and is dependent upon the CPU to CPU. So they can be different depending upon the type of instruction and it can be different depending upon the type of CPU. But basic operations are same. Now suppose guys, this was my instruction. Move A, 10. Move A, 10. So what control unit will do? When it gets this instruction from the instruction register, it divides the instruction into two parts. First part is called as opcode. And second part is called as operand. Operands. Here it split the instruction into two parts. Opcode tells what type of operation I have to do on the following operands. So this instruction tells move A, 10 means move the data in the instruction to CPU register A. A is also called as accumulator. So it will split the instruction, then it will see, okay, this is a move instruction. So I need to move this data to CPU register A. So then it will generate the control signals which will move this data from the instruction to the accumulator. So what comes in the accumulator? 10. Okay. Suppose I have another instruction, move B, 20. Again it splits the instruction. Okay. This is also a data movement instruction. So whatever data is written in the instruction, I move it to CPU register B. Okay. So data is moved. 10 comes to accumulator, 20 goes to register B. Okay. Now suppose I have next instruction. What was that? That was add B. that was add B. Again, the control unit will split this instruction into two parts. Okay, what is the opcode? Add. So add, CPU comes to know. Now it is not a data movement instruction, so I need to add two values. So I have to perform a arithmetic operation. To perform an arithmetic operation, CPU has another part. We call it as ALU. We call it as ALU. What is ALU? Arithmetic and logic unit. Okay. So then what it will do? It will generate the control signal to move the contents of accumulator to ALU. So it will generate the control signal saying whatever is in ALU, move it to input number 1 of accumulator using this internal bus. What is internal bus? It is the bus which connects the different part inside the CPU with each other. So at input 1 what goes is 10. Then again it will generate the control signal to move the contents of register B to input 2. So what are the contents of register B? 20. Where they are moved? To input 2. Okay, now the data comes to my ALU. So now ALU will perform the arithmetic operation add. So then it generates a signal add, control signal, and instructs the ALU to add input 1 and input 2. So ALU will perform the addition. So 10 plus 20, it becomes 30. So two numbers are added. Now what it has to do? It needs to add the content of register B to accumulator and store the result in accumulator. Now this is the result. Again it generates another signal which sends the result back to accumulator. The result comes. So now earlier accumulator was 10. After adding 20 to it, it becomes 30. It becomes 30. So guys, in case you are getting confused with the accumulator, let me tell you, accumulator is a CPU register which acts as the source of data and the destination of the result. In the first part, it was source of data when it stored 10. So after we did the operation, I added 10 and 20. Now it is acting as a destination of the data. So don't be confused. Okay. So guys, now my instruction is decoded and executed. So guys, I hope you understand it. Okay. So guys, in case you like my videos, please subscribe to my channel, share it with your friends. I'll be uploading more of IT lectures and all kind of stuff. So guys, all of you, thanks for watching and stay tuned.